exercise 46. So let's classify orthogonal transformations R2. So which means basically those 2x2 matrix lies in this orthogonal group of R2 with respect to the dot product. Actually, we know what are them. So by previous exercise, this is those MTM equals identity. Right, so which means you could classify it. I mean, when I say classify, this is already some kind of classification by right on precise matrix. There will be basically two types of matrix. So the first method, I would say, what do you just work with m equals a, b, c, d, such that MTM equals identity, and you just do computation, you will see that s squared plus s squared equals 1, b squared plus d squared equals 1, ab plus ad equals 0, and then you could see that there exists some theta such that equals cosine theta, z equals sin theta, correspondingly some theta prime, b equals theta prime, d equals sin theta prime. Well, the third one will tell you that actually cosine theta minus theta prime equals 0. And this further implies theta prime congruent to theta cos pi over 2 mod 2 pi. So their difference, mod 2 pi equals pi over 2. Or their difference equals minus pi over 2 mod 2 pi. Or you could summarize to say the difference equals pi over 2 mod pi. And so in the first case, this is then could be written as cosine theta minus sin theta. Sin theta, cosine theta. Which corresponds to rotation. Anti-clockwise. Pi theta. The second case, this becomes cosine theta sin theta because sin theta minus cosine theta because as what we discussed here. This is saying that we can write our matrix M as cosine theta sin theta, cosine theta prime sin theta prime, right? And so this corresponds to when theta prime equals theta plus pi over 2, we have cosine theta plus pi over 2 equals minus sin theta, and sin theta plus pi over 2 equals cosine theta. Similarly, this corresponds to cosine theta minus pi over 2 equals sin theta, and correspondingly. And the second one corresponds to reflection with respect to the line. Passing through. That's a span of cosine theta over 2 sin theta over 2. So let me give the second method. So it's very similar but more geometrically or intuitively. So actually I could first put a remark of the first method. So totally algebraic discussion in the first method, but let's say actually what you're doing is notice that if your m is cosine theta sin theta minus cosine theta prime sin theta prime, then as matrix transformation or linear transformation, it corresponds to mapping this E1 to m times E1, which is exactly this cosine theta sin theta, and map this 0, 1 to exactly correspondingly cosine theta prime sin theta prime. Right, so geometrically what we're talking about is we firstly preserve the length, everything is still on the unique circle, so this 1, 0 is mapped to some theta. Okay, this is not necessarily the rotation. Actually, we will see our final result has there are two possibility. One is rotation, second is reflection. So this 1, 0 is mapped to this theta, and 0, 1 is mapped to, there are two possibilities. Basically, you could see this two possibility from the fact that orthogonality preserves orthogonality are preserved, right? So this is orthogonal, and so when our t of 1, 0 is fixed, this is 1, 0. I would rather write this as vector 1, 0. So there is only two possibilities for t01. Either this is the t01 or either this is the t01, because you have to preserve orthogonality. This corresponds perfectly to theta prime, because you see we call this angle of t 0, 1. So it will be either this one or either this one. This is our theta prime. Exactly. And so it corresponds exactly to theta prime equals theta plus pi over 2 mod 2 pi, or theta prime equals pi theta minus pi over 2 mod 2 pi, right? And if you think of it geometrically, you will see that in the first case, you're exactly mapping this after your matrix transformation to TE1 and TE2, while rotation by theta counterclockwise, right? The first. And the second case, what you do is C0, E1, E2. Finally, what you do is this is your TE1, this is your TE2. How do you got this? This is reflection. It's not that obvious, but think about it. You see, maybe it's better to put in the unique circle again. And you see that this is your T E1, this is your previous E1. You're doing the reflection with respect to this. And so your triangle, this reflect to this, and this reflect to this, which means these two are the same angle. This corresponds to your TE2. This is your E2, E1. Right. And this corresponds to the reflection. This gives the classification of the two kinds.